Hi everybody. Today's video we're going to talk about using the intercept formula to essentially um, do a goal seek on a data table. So you might not be familiar with the what if analysis, goal seek, and data table. Um, I'll go through my scenario here so we can have an example to use it for. Um, and I don't think I'm the first person to use this to realize this, but I'm probably very rare that this has been discovered. So we have simple mortgage or annuity. We have a price, down payment. We have the mortgage, um, that portion here, the interest rate, the term. So this is the monthly payment. I have another sheet here that actually amortizes the loan and has a schedule. But here, this annual payment is not the annual payment, but it's 12 times the monthly payment. So there's the mortgage portion. Then we have some random. We have a income statement. So we basically have a scenario where a company or we we're doing a mortgage. We are paying a mortgage off, and we also have another operation. We have two operations going on at the same time. We also have an investor that we have to pay back. So this investor invested into the down payment. So we have a non-mortgage income. We have is this. Then we have net of mortgage is 0 because annual payments equals exactly the same as our income. Then their investor's expense is 12% of the dollar value there, of 12% of the 25%. So we have a negative net here. But this break even, this formula, this box here is, we want to know what is the building price that would give us a break even. So right here, this is calculating a break even before this investor expense. This is why it comes out to 0 here. If we put in a number higher than our break even, 17 million, we get a negative here. If you put in something lower than 16, oh, sorry, not that way. If you put in over here, how many zeros is that? 16 million. We still get a negative there. Let's kick it up straight up to 15. Kick it down, I mean. We still get a negative number there. How would we get a break-even net after the investor's expense? So this is just basically working backwards, reverse engineering this part, which is simple enough. It's just basic algebra, pre-algebra. We want the present value divided by the mortgage ratio, which gives us a price, and in the same rate, the same periods, but we have for the payment of the present value formula is our net income of the side operation divided by 12. So if you take our net income divided by 12 is basically what we can afford to spend on the monthly payments for annually. So that's how we get that break-even number. To get a number for this break-even is, let's copy this formula. I didn't set it up completely, I only did it partially. We would need to, in theory, we would want to add here to take up to basically how much more are we spending here that we can afford, how much more so that we can't afford that much in the monthly payment. So we would do basically this 12%, times 25% of the original, or we can just do 25%, 12% of the dollar value. Problem with that is circular, because this is based off of the original, and we want to know this C6 is what this is trying to get to. So it's circular. That's why that won't work. What will work is if we made a data table. This thing that I mentioned earlier. So goal seek would do is you have to do this every single time you change the values and you want to do it. So set cell to 0 by changing this one. Okay, there we go. But if you want to do that every single time we change it, we have to either do VBA or, you should have to do it you have to do it every time. That's not dynamic. So the other thing to do is step before goal seek is the data table. What's the data table? Is if you have, let's just say 20 million here. I'm not sure if that's a million. I can't count zeros. Yes. And we step it down by 1 million. Okay. And right here, what we do is we have to, well, actually, instead of making a formula ourselves, is if we take this number here, we make this equal to that. So it's essentially, this is our end results cell. We highlight the table. We go to data table. It's a column input cell because we have a column-based data table. Column input cell is, this is the cell that these are representing. Okay, enter. Now we see if we tell it we want dollar values, you can see that we have an arrangement, and it looks like it's a progressive, it's a line, it's a curve. Question is it linear or a exponential? To find out, we can either get a visual like this. So it's linear, it looks like. To confirm that it's linear, we can do equals intercept. And this intercept formula on the data table is, sorry, before the intercept, if you do equals slope, known y's, this is the y-axis, known x's, this is the x-axis. In fact, I think I might have this back to front. I'm just going to enter it for now. Yeah, I have it back to front. It's about 11 million. And because it's a linear curve, so it's a line, not a curve, the slope is the positive of the slope is the y-intercept, which is the break-even price, which we'll get to. I'm jumping the gun, but if we go to select data, we can edit the horizontal, tell it we want to use this. Okay. Edit series. We're going to call it price, because that's our price. And we're going to tell it we want to use this series. So we're basically flipping our data set. If you did switch row column, it wouldn't do that for us. And we see why it's negative, because the further x we go, then the negative y we get. And it's actually 11 point whatever. So our slope is magnitudes lower, orders of magnitudes lower, but it's the same digits, it's the same numbers, because as I'll show you, equals intercept. This is my breakthrough. Intercept, there we go. Intercept of the same y's. We will get the exact same numbers, but to a different order of magnitude. In other words, moving the decimal place around. Now, I'm not sure what the relationship between these two is exactly. If we look at here at this, you understand y is a negative, but how do you convert that? I guess you just have to plot it, but there's for sure a mathematical relationship between those two. If it was a curve instead of a line, then it would be different. It wouldn't be this simple. But even if I don't really fully understand that part, but that was my breakthrough. Probably just my own personal discovery. Probably not that big of a deal. But so we constructed a. So here it's a data table, so it's not a formula. It's Excel is doing its own thing here. So if we change one of these values, we put in 5,000 here, it would change everything. It would update our data table, and you see here that our visual represents that. Fine. And it looks like our y-intercept is the same. Our slope is still the same, even though we changed that, because it was basically the average is still the average here. Let me change that back to there. Okay. So if you use a y-intercept on a data table, you will get the goal seek. If your goal seek is seeking a 0. And I'm not sure what the official terminology for the y-intercept at the place other than 0, but any place y-intercept on any place on the x-axis is the goal seek of that spot. So if we manage to build a table, if instead of using the data table feature, which if you don't want to use this feature, we want to make a formula ourselves, which is entirely possible. There's not that much data that is too hard. We could write the formula ourselves and drag and autofill it down, so we could have a dynamic. We could instead of having this formula here, we can you say intercept equals intercept of the table. Give it a dollar value. And if you plug this in, paste, we get a 0, and we're all done. I didn't actually do the math here for you, the formula. Let's do it. You won't need this to check our work, because if we do it, I mean, we'll know if it's right, if this equals 0. So let's do it together. We know that we need the payment formula, and the payment gives us a negative, so we want to negative the negative. We have a rate. We need it to F4 to keep it on that spot as we drag down, divided by 12 for the months of the year. We want periods. That's our periods times 12 for the 12 months. Our present value is this number that we want to be relative. We could do this negative and this positive, but it doesn't really make a difference. We don't need to do anything else. Default future value is 0, because this is a mortgage. If you wanted to do it in an investment scheme and see what our money would lead us to, we would do a positive future value there instead of, yeah. Okay, next. That's our payment. We want to know, now we want to take off, we want to subtract our payment. So we could just leave it as a positive to make it a negative, but I wanted to I want to duplicate it. So it's more obvious that it's a negative. So we want to take our income, keep it there, minus our expenses, minus our payment, and we need to multiply our payment by 12. Let's put that around there. What else do we need to do? So we take our income minus expenses minus the payments, and now we need to do minus 12 times 25 times there. And before I forget, lock the 12 and the 25. Keep this one, keep the 20 million relative. This we'll do it first, or order operations. This will happen first. So this should be correct. I could be wrong, but it's a y-intercept 9 million. I think I got something a little bit wrong. I think I caught it. I forgot to multiply my price by the mortgage. And also I caught this here. This should do it. Yes. So there you have it. You can look at this formula. So the point is, as long as you can manually or build a data table on your own with the formula, which is essentially combining all the formulas into one spot, then you don't need to use the data table. And once you get that, you can use the y-intercept, as long as you have a line, to get the goal seek, to get a break even. That's the point. Thanks for watching. Like and subscribe.